Welcome to The Explainer. If you've been watching the world of artificial intelligence lately, you might be feeling, well, a very specific kind of exhaustion, right? Every single day there's a new model, a new framework, some new term you're suddenly supposed to understand immediately. You might be sitting there with 12 browser tabs open, trying to figure out where to begin, and honestly, just absorbing panic instead of knowledge. Well, let's take a breath together. We're going to slow it all down today. We're not looking at the hype. We're not memorizing complex equations. Instead, we're going to build a calm, sturdy foundation from the ground up.
Because really, what does it actually mean for a machine to learn? That is the core question we have to answer here. Just imagine someone trying to solve a real, everyday business problem. They're surrounded by all these trendy tools, complex dashboards, AI agents, but they completely lack clarity. The instinct is usually just to grab an algorithm and start building, right? But that reverse order is exactly why so many projects fail. We don't start with the machine. We start with us.
The model is not the first step. The question is, I really want to let that settle for a second. This anchoring truth is going to shape our entire journey today. Because before the data, before the math, and long before the artificial intelligence, there has to be a human being with a real question that actually needs answering.
So let's dive into our first big idea. The question comes first.
Starting with a clear, solvable problem is absolutely non-negotiable. I mean, if you don't know exactly what you're trying to solve, a complex algorithm is just going to give you a very confident, totally useless answer. Because at its core, machine learning isn't magic. It isn't some digital brain that just automatically understands your business. It's simply a disciplined way for a system to learn useful patterns from examples. That's really it. It kicks in when a useful question can be answered better by learning from past evidence, rather than having a human sit there and manually write out thousands of rules.
Let's ground this in reality for a second. Imagine a retail store. The store managers and operations analysts are completely overwhelmed. Raw data is scattered everywhere, across different sources. Sales, inventory, promotions, they're incredibly hard to track manually. Because of this, managers are just reacting to damage, like an empty shelf, instead of preventing it. So what's our real goal here? It's not to build an AI to replace those managers. No way. The goal is to surface patterns to support their operational judgment.
Moving on to part 2, how a machine actually learns.
So how does the system actually go from looking at scattered retail data to knowing something useful? Well, it happens because learning, at its most basic level, is simply improvement through adjustment and feedback. Think about how we learn as humans. When a kid learns to walk or an athlete practices a basketball free throw, they don't get it perfectly right on the first try, do they? They make a movement, see what happens, and they adjust. A machine learns in that exact same, deeply human way.
This right here is the elegant, universal loop of learning. And look, without a single mathematical equation, we can understand the engine of modern AI. It's just 3 steps. Step 1, the machine makes a prediction, like guessing how many units of a product are going to sell. Step 2, it measures the error, which is just the gap between its guess and reality. And step 3, it adjusts its internal parameters so it can do a little bit better next time. What's truly fascinating here is how this completely reframes our whole idea of failure. In machine learning, an error is not a bad thing. Error is the crucial feedback that gives the model its direction. It's like standing on the side of a hill in the pitch dark, trying to get to the bottom. Every step that takes you downward reduces your altitude. For a machine, every adjustment that reduces error is literally a step toward intelligence.
Which brings us to our third part, naming the target. Before that learning loop can even start, we have to name the exact outcome the machine is trying to predict. We call this the target. If we don't define the target, we really haven't defined the learning task. A vague target creates a vague and completely useless model. You can't just plug in a machine and tell it, hey, optimize the business. You have to be incredibly specific.
Look at how we can translate a vague worry into a learnable task. Instead of asking a broad question like, why are we losing money, we ask the machine to target the likelihood of a product stockout next week, or the probability of a sharp sales decline. By naming a specific, measurable outcome, we suddenly give the machine a clear finish line. We give it something it can actually practice against.
All right, part 4, features translate our reality.
So the target is what we want to know. But how do we actually feed our messy, complicated physical world into a neat mathematical model? Well, we use features. These are signals chosen deliberately to help the model learn. They aren't just thoughtless columns of raw data dumped from a database. They are careful, intentional representations of reality. The reality is, the model doesn't actually see the world itself. It receives our translation of it. If you feed a machine a raw calendar date, it might just see a random string of numbers. But if you design a feature that translates that date into day of the week or proximity to a holiday, well, now you're handing the machine a signal it can actually use. Good human design essentially reduces the machine's confusion.
There's honestly a kind of magic in this translation. Think about it. A physical car, a messy apartment, even the concept of a dog. They're elegantly transformed into mathematical vectors, which are just lists of carefully chosen numbers. This is how the system organizes space. By converting reality into these features, the machine can suddenly calculate similarity, identify patterns, and begin to kind of understand our world.
Let's move into part 5. Training data is memory.
It is time we stop thinking of data as just some boring, endless spreadsheet. Training data is the foundational memory of the machine. But a trap so many beginners fall into is thinking that just having millions of rows guarantees a smart model. It doesn't. Relevance always beats volume. If you train a retail model exclusively on data from the super busy holiday festival season and then ask it to predict sales for a quiet week in February, it's going to fail completely. Its memory is just entirely wrong for the current task.
The quality of that memory dictates absolutely everything. A machine will loyally learn whatever you show it, and yes, that includes your mistakes. If there was a sudden policy change in your store or some historical bias in how managers ordered stock, the machine is going to smuggle that noise right into its memory. It will learn your bad habits perfectly. So we are ultimately responsible for the quality of the examples we provide.
And that leads us to our final section. Evaluation protects our judgment.
Once the machine has learned its patterns, how do we hold it accountable? Listen, a single accuracy score on a dashboard cannot possibly capture the true weight of a mistake in the real world. If our retail model overorders fruit, we have waste, it eats up budget. It's like a smoke alarm that goes off when you burn toast. Super annoying, but you're safe. But what if it underorders? We lose sales, we disappoint customers. That is like a smoke alarm staying silent during an actual fire. The costs of these mistakes are completely different, and our evaluation absolutely must reflect that human reality.
A model is not evaluated responsibly until the kinds and costs of mistakes are visible. Evaluating AI is a matter of profound human responsibility. It's not just a math problem. When a model fails, those failure modes aren't insults to the system. They are maps. They show us exactly where human care and judgment are still deeply needed.
So we end right where we began, with a question. Machine learning relies on the targets you name, the features you design, and the memory you provide. Yes, the technology is incredibly powerful, but it is entirely blind without you. The question isn't whether the machine will learn. The real question is, how will you guide it? Thank you so much for joining me on this explainer. I really hope you leave feeling grounded, clear, and ready to lead.